Okay, so I've heard 2 people got in trouble this weekend. I don't know who, for fishing in the church hole, because you're not allowed to fish in the church hole. I know who one of them is. I went fishing for the first time. I took Zeke fishing this weekend for the first time, like got him a little fishing pole and everything. And I don't know if you've ever spent much time with a 3-year-old. You obviously were once. Not a lot of fun if you're not catching fish. He hung out with me for 90 minutes and didn't complain or ask, like, he just sat there and casted with me. He can't really cast, so yeah, he was good about it, which is awesome. All right, so we're trying to do some piecewise functions that as long as you deal with the pieces independently, they're easy. So let's dive in. We assume, I would assume we start with the top function. Okay, we had an x that we're going to choose. We're going to plug it into 3x minus 1. This is just all my work. And we're going to see what y it spits out, yeah? Okay, with, like, you obviously have the table on your notes already. How did we decide the first x that we're going to pick? Because I bet it's -1.
Because it says, because you start with the first
boundary.
boundary.
The first boundary every single time. Always include it. So when I look at the top function and I see that it's only defined for this boundary, that's the first number we're putting in. Okay, I assume that there's also probably this mark next to your -1. Why? How do you know that? Included or equal to closed point. If it's any point other than the boundary, we don't have to worry about it, ever. Okay, so when we do this, and you guys, I think already did it, but I just want to kind of get the cognitive ideas going again. Anywhere there's an x, I replace with a -1. What's 3 times -1? -1. -4. If we add 1, it'll take us back. Okay, give me any other number.
-2.
Okay, that's what we chose. Give me another number I could pick.
-3.
-3, -4, -1.5. Any of those would work. We had 2 in our notes, right?
Yeah.
So 3 times -2, -1. What's 3 times -2? -1? -7. Now, is this in the form of mx plus b?
Yes.
Which means it's a line. Which means I need how many points to actually draw it?
2.
Just 2. Any 2 points, you can draw a line through it. Okay, so we have 2 of them. All right, we did not do anything else, right?
No.
All right, so let's get to it then. We're going to deal with the bottom function here as well. And I usually, BTM is how I shorthand that. And I don't know why I switched colors here. That's my bad.
What does that stand for again?
Bottom. Yep. And I suppose I can take the 5 seconds to do this. All right. So we have x. We have x plus 1 is our function that we're going to plug into. And we have the y it spits out. First thing that I care about, and realistically it's the only thing that I care about at this part of the problem, is we got 8 people in here. Number 7, if your phone rings and it's not in there, your parents are going to have to come get it. If you don't have it, I believe you, but I don't know who it is. All right. Number 7, who dat? Is that this number I just said? God, just calling them out. Now I'm going to know who it is. Declan!
I'm 6.
What?
Right?
No. You're 7. I'll move you. All right, Declan. What value of x am I going to first choose?
You're gonna use
I said it was 6.
1
Why 1?
because it's the first boundary.
So be really careful. We're doing the table for which function?
Bottom.
The bottom. Look at the boundary of the bottom function. X greater than what?
0.
Let's
So
use that.
You would use 0?
Yep, we're going to use 0. Whatever the boundary of that function is, every time.
I thought that meant like since the other one was equal to, you would use -1 since it's equal to, but this one wasn't.
Yep, because I'm never going to be able to plug -1 into this bottom function. We're always just going to focus on this part to decide where do we start. Every time. So I'm going to pick a 0. I need, Wenzel, a mark next to this to indicate to me so I don't get goofed up when I actually graph it. Is this going to be an open point or a closed point? Why? Was that a guess? You had 50% chance. So I'm going to switch a question. How do I know it's not closed based on this statement? Not the part that I'm super focused on. It is 0. What if I underline it? What does that mean? If I were to underline it right here, what does that change inequality? How would we read it without it underlined? X something 0. And that's okay, because if you didn't learn math and English, that would make sense. Somebody help? Greater than. If it's or equal to, we fill it in. Open. Okay, so anywhere that there's an x in this function, in this rule, we replace it with a what right now?
0.
So here we go. 0 plus 1. It's 1. Yeah, okay. Give me any other value that I can plug in according to that rule, Jade. I chose x as 0. 1 works. As long as it's greater than 0, you're good. So here we go. 1 plus 1. Indeed it is. Is this also just a straight line?
Yeah.
And how many points do we need?
2.
Hey, we got 2. Awesome. Okay, here's the deal. Your graphs do not have to be perfect. If you disagree with that, that's totally within your right. I'm not going to spend like a million years waiting for you guys to draw perfect graphs. However, if you want to pass these around, you can stick them in your notes if you want. Don't take like a whole stack. I'll always have them available for you guys. But we're going to graph, and I don't like having to take all the time for you guys to draw your graph. So you have a graph in front of you, a nice coordinate plane. I'm going to draw mine here with much less detail, and then we're going to make sense of this. Now, when I ask you guys to graph, how many of you, and I know that we're like doubling the class right now, if I just said graph a function, how many of you automatically start with a big plane like this? Okay, you're allowed to. You're good with it. Here's my suggestion. I would spend a little bit of time looking at it just to make sense. What's the furthest left x value we ever chose?
-7.
So that's a y value though.
Oh.
-2 is the farthest left, right? And then we did as far right as +1. Which means as I'm thinking about this, I would only have this go from -3. I'd always go one more. -3, -2, -1, and then here's my 0. It's going to happen right here. I would not bother drawing the 10 by 10. It's a waste of space. Okay, and the y's, more up or more down? What's the lowest value? 1 is the lowest y value? -7, right? So -2, -1, here's my -2, -1, here's 0. So when I'm looking at this, I realize that I need to go down to -7, but I only have to go up to 2, right? If you want to just draw your big scale, you can, but I have no issue if we make it skew to fit whatever it is we're trying to graph. If you hate this idea, cool, don't use it. My graphs will always be zoomed in around where we're looking. Okay, and then I'm going to be really lazy with my scale. I need to go up to 2, right? So check it out. There's 2. Here's -2, -4, -6. I give it to go a little bit further, down to -7. It's a dash with a 2. And then here's -2, here's -4, -6, and -8. The understanding that I will always work with is if you have ticks on a graph but no label, I always assume it's 1. So if it is going by 1, you don't even have to label it. Any other number, like I did with 2, label at least one of them so I have your scale. Okay. Y'all ready to graph?
Yep.
Cool. I was expecting bump, but it's okay. Well, here we go. Let's graph top function first. Okay, mine's in red. I'm always going to plot my boundary point first. So when x is -1, what was the y value? -1, -4. Open or closed? Closed. So there's -1, -4. I'm going to plot -2, -7 as well. Do I even have to think about open or closed?
Yep.
Why not? You're right.
Because the first one was closed, and it's line, so.
So I don't even care about what happened with the first one. If it's not the boundary, it's always closed. Always. Okay. Everybody have these 2 points on your page?
No. What's the
Okay.
second one?
-2, -7. Before you connect them, I'm going to make you guys look up here, but I'll wait until everybody has the points. Everybody has 2 points. If you want straight edges and stuff while you're drawing, did I give you guys some already? Yeah. Okay, if you ever lose yours or you've lost however many, I don't care. There's always some up in here. Anybody need one along here? Okay. Still, hold off on the urge. Don't draw your line yet. You know what? We're just going to put a stack of them right here. Anybody in here blind and wants the front row seat, you're welcome to it as well. All right. Everybody has 2 points.
Yeah.
Okay. terrible way to ask that question because all I need is one yes and I'm given like a go ahead, right? Anybody need more time to draw their points? Okay. So, check it out. This is my boundary at -1. When you're graphing piecewise, you're going to put your pencil down at your boundary point first. I'm going to put it down here, and then I'm going to go through the other point and no further. And what I mean by no further is I'm never going to draw for this red graph. I will never be to the right of -1, ever. Always, always, always start at the boundary, every time. Okay, this is our top part. What I'm going to ask you guys to do, I'll pause it. I want you to do the second part as well. And then I assume I'm going to find some mistakes that you guys will have to fix. Not a threat. It's a good thing if you make mistakes. I want you to plot these points and graph the second part of our function as well. Cool. I'll give you a second. 2 more points and 1 more ray or line or segment, whatever it is you're going to draw. And we'll come back together and make sense of it. All right, Jade, I want you to find your mistake because I think I saw it, but if I wasn't looking closely, that's my bad. Okay, everybody plot the point 0, 1, like right here. Okay, I want you to tell me the first thing I've done wrong.
Oh, you colored it in.
Ah, it's supposed to be open. Okay, easy to fix. You had it. You're still good.
Oh, I missed that one too.
Did you do 1, 0?
Yeah.
Okay, I did not even notice that. Okay, 1, 2 is like right here. Desi, open or closed?
Open. Close.
Always closed if it's not the boundary. Okay, now here's the part where I'm expecting mistakes to happen. Where do I put my pen, pencil, whatever it is I'm graphing with, down to start?
The open one.
At the open one, the boundary, right? So here I am. I'm going to put it down here. I'll grab my straight edge, and then I only go through the only go through the next point. Now, this thing, we were told that it's anywhere that x is greater than 0, right? How many numbers are greater than 0?
A lot.
All of them, all the way out to how far?
Infinity.
The arrow here. Now, I'm going to show you common mistakes. Jade, did you see what I had possible? What was your mistake?
Open.
You had an open point right here, yeah? Okay, easy mistake. Other really common mistakes. Somebody will get these 2 points, and I'm going to undo it, and say, oh yeah, check it out. What did this person do wrong?
They had it go the wrong way.
Where they should have put their pencil on that boundary point first. If you always remember pencil on the boundary point and then through your next point, it'll always work out correctly. Okay, there's a really neat question that always follows pretty much any time we talk about a function. 2 things that are always a follow-up to these. What am I asking you for? The domain of this function. And if I'm going to ask about the domain, I'm also going to ask what?
Range.
The range. Okay. This one, if you weren't clear on it before, we're going to clean it up right now. X is our domain or range. So I'm going to use a vertical line is what I use to check this. Okay, so I'm going to copy it. You can't draw it. I would just use your protractor if I were you. Okay, check it out. If I go out here, if I let all these lines extend to infinity, would it eventually touch this red one down here?
Yes.
Yeah.
If I moved it over here, would it still do it?
Yes.
It'll do that as far left as I can possibly go, which says my domain begins where?
-1.
Further. How far left can I go?
Infinity.
So to negative infinity, right? So I can start my x's at any negative infinity and start working forward. So what I mean by that, Declan, is no matter how far I go, like even if I come over here, eventually it's going to hit like down here, as far left as I want. Okay, so you guys let me know when I run into issues. Am I still touching it? Or would I be?
Yes.
Still?
Yes.
Still?
Yes.
Where am I going to get weird?
At the dot.
Here.
Closed. Yeah.
And do I touch it?
Yes.
Yes, it was closed. I will touch it. So, what? We'll just copy that. I don't know what I just did. We'll fix that. So we started at negative infinity and we ran to where? What x value did we get to where it got weird?
-1.
-1 was the x value, and I'm looking at this x value. Okay, and we included it. How do I indicate that? Parentheses, don't touch. Bracket. Okay, Do I hit any other x values? I do. Now, there's something weird that happens with this one in particular, because check it. Am I ever going to hit what? Not am I going to hit what? That was... Am I ever going to hit this x value at negative 0.5? Does that ever touch my function?
No.
No, so we need to take a jump. Until, what's the next value that I might get close to hitting it?
The open.
And what x value does this happen at? 0? Do I actually touch it?
No.
No, so that's a parenthesis. So starting again, we'll tie it together here in a second. But 0 to, am I still touching? Still? Can't see it, but am I still touching? How far to the right will I go?
Infinity.
So we just decided 0 to infinity. Love it. Okay, to tie together two intervals. Union. Just a U. And we said we start at 0 and we went how far to the right? To infinity. Now, you don't have the ability to draw that line. I would just use a straight edge. I want you guys to try the range. I'm going to give you 30 seconds. I'll give you a minute. Talk with your neighbors. I'm going to call on somebody random. You're a small enough class that I can pretty much hear all your conversations, so I'm just going to pretend like I don't. Cool. How low do you go? Or this is the U, but negative. Negative infinity. All right, so the only thing that changes is if I'm checking y values, I'm going to think about a horizontal line because that's easy for me to see what y value it's at. And let's check. I start at negative infinity. Things are good, going great, awesome. Things are good, still touching, still touching. What's the last place where things get weird? Negative 4. Do I actually touch it?
Yeah.
Yeah, it's closed in. Of course, yeah, 100%. So, let me do this real quick, to negative 4. Am I ever going to hit any of these y values in between?
Never.
Nope, my function doesn't even exist there. So I'm going to union this together. And where does my graph pick back up? At which y value?
1.
1. Do I include it?
Yeah.
Open circle. Should I include it? Lucy, I lost you there, I think. Let's do this.
If you don't include it, then why is it in?
So it's kind of in. And here's the issue that we run into. And I'll just show you real quick. Like, we have to make the whole clear, yeah? Because we have to be able to see it. But like, let me make a function. I'm going to show you a function that breaks when x is 1. Okay, so if we do this. If I plug in a 1, that's a terrible example. X minus 1 over x squared minus 1. Okay. Oh my gosh, it's another terrible example. Time out. Why am I having trouble thinking of a weird example here?
Use ours.
No, we're just going to switch these. X squared minus 1 needs parentheses. Over x minus 1. Here we go. Okay. This function breaks when x equals 1 because it makes me divide by 0. It's not allowed.
Okay.
We would have a hole in our graph. Here's Desmos' graph. Can you see the hole? Here's 1 even. Can you see the hole there yet?
No.
Like, it'll show me, like, when I get to it, it says, yep, it's undefined, but check this out.
Well,
Do you see it yet?
no.
Okay.
Am I supposed to see it?
Do you see it yet?
No.
Points are infinitely small. We can't actually see it. When we draw ours, like Desmos can't even do this. Your calculators can't do it. There's a hole in this graph, but because points are so small, we just can't physically see it. So we get to be really obnoxious with it. When we include the 1, because I agree with you, like it's weird that we write it because it's not included, right? But is 1.00000000001 included? Like something a little tiny bigger. Or 1.0000001, it's also included. There's no way that we can draw that y value. Instead, we say, hey, look, here's a whole, like, open point. Get as close to 1 as you want, or 0 as the x value, but we'll never actually quite get there. Like, as close as possible. So we take our jump, we pick back up at 1, but we don't touch it. That's the hole. How high up will it keep going where I can touch it?
Infinity.
Boom. Okay. 1 to infinity. And we have it. Okay. We're going to do one more. Are we doing one more together as a class? Are we doing one more? I'll give you guys a head start, and then I'll start doing it. And we'll compare. Cool? All right. So help me make a piecewise function. We'll call this example B. And we don't have a ton more to do other than just make sure we get these locked in. So we should have a little bit of time. I hope the rain stops. Unrelated to anything that we're doing. All right. B. We're going to do 3 pieces here, I think. And let's knock it out. F of x is equal to, we're going to get real crazy. I want -2 if, and then we're going to write a compound inequality. Just means more than one. -3 is less than or equal to x is less than or equal to -1. We're going to use, I don't know, what's your favorite linear function? 3x. If -1 is less than x is less than 1, and we're going to use, we'll say 1. We'll switch color. 1 if, let's say 1 is less than or equal to x is less than or equal to 3. Here's our lovely piecewise defined function. How many pieces? Which means I'm going to hook you up to begin with. We have a top piece. We have a middle piece. If you're, sorry, let me finish this first. And we have a bottom. If you don't need all 3 columns, I don't care if you use it. So like maybe you won't use all 3 columns on the first one. I'm going to give you guys a couple minutes. I'll give you like a 60-second head start, and then I'm going to start working it, and then we'll compare our work. Cool. Who can you ask if you're having trouble? Your peers. Anybody else? Maybe your peers don't know or don't want to help. It's my job to help, but I think that we'll be able to get there if you combine your brains. Cool. I'll give it a minute. Okay. B, you were on the right track right off the bat. Lucy.
How would you write that down if you did it 3-column one? Would you just not write the equation?
Well, this one's weird because there's nothing to really do. Like, do you see how there's no x to plug in here? So when I try to put the parentheses around and plug my x in, look, I just did it.
So then it's -2.
Yeah, it's still -2. This is a horizontal line. It's always y equals -2. There's no change in slope.
Okay.
So you seem uncomfortable with that. We'll get it. When I plug in a -1, is there an x to even plug in here in my equation? Like literally, when I say this is what it's equal to, is there an x in this middle part right here?
No.
So check it out. I'm going to plug in a -1 for the x that's not there. Like, there's nowhere to plug it in. So what does it still have left in here then? So check it. We're going to come, we'll be right back. I'm going to graph y equals -2. And I'm going to zoom way out because I'm like 1,000,000% zoomed in right now. No matter what x I pick, what y value does it give me?
-2.
That's what we just saw. There's nowhere to put an x in. We just did that. Cool.
So in certain equations, you only need to do 2 columns?
So I'm going to be honest. You can use 2 columns anytime you want. But if I ask you to graph something by hand and you don't do any of the scratch work to get the y value and you're wrong, there goes all your partial credit. Like, it's so that I can see that you're doing, because you can graph the right stuff and just have the wrong things written down. And if I know that you were doing it, you just made a silly mistake, I won't burn your whole problem. Okay, let's do the middle one together. What are my boundaries that I'm going to put on here? Y3. Are you looking at this number? All my boundaries are here. Somebody said, I don't know who said it. -1, because it's this number. Okay? Open or closed? Why?
Because you can't go on it.
Yeah, it's no or equal to. So I start at that -1, I'll put an open. And then, like this one, would you like a 3-column table, Lucy, just so you can see it?
Wait, why is it open if it's not? You can't get. You're not on it. Like,
Yep, you can't be equal to it.
Oh, I thought that I got it switched.
Nope. So if you wanted a 3rd column, and entirely up to you, Lucy, okay? But I'll show you my 3rd column. What is the rule for this function? If I'm between -1 and 1, what equation do I plug it into?
I don't know.
So here's the equation for the top one. Here's the equation for the second one and for the third. It's 3x is the rule, right? Because I say use this rule if you're picking x's in here.
Okay.
So if I do a 3x, and here's why I would make the claim I don't think we necessarily need it. When I plug in a -1 for this x, which I can actually do because there's an x here, what's 3 times -1?
-3.
Yeah, I agree with you.
Oh, I was like, wait.
Sorry, I had a brain hiccup. And notice, could you have done that without that middle column?
Yeah.
Yeah, don't include it if you're confident in yourself. What's my other boundary condition, Desi? -1. And what about for this middle one? -1 to where?
1.
Good. Is 1 open or closed?
Open.
Is that a guess?
No.
Okay. Why open?
Because it's not equal to bigger.
Love it. Your tone makes you seem a lot less confident than you should be. When I plug in a 1 for x, I get 3 times 1 and I get 3. Cool. Bottom one, I want you guys to knock out. I'm going to give you like 10 seconds, and then I'll write mine. Do you want... I'm not going to do 3 column because it's a constant. Jade, if you got the third table, if you're done with them all, you're welcome to start graphing, and I'm going to judge the heck out of your graphs. Are you already all graphed? Baller. I'll come check it in a second, okay? As a class, what numbers go in the x column here? 2 of them have to be there.
1 and 3.
1
Closed.
and 3
3 closed.
closed. And no matter what, is there I don't know why I'm struggling. Is there an x in this equation?
Nope.
So no matter what I pick for x, what's it spit out?
1.
No matter what, it's always 1. Only because there's no x here. Just like this one was always -2, this one's always 1. Okay. Big challenge. I want you guys to graph it. 60 seconds, I want you to graph it, paying careful attention to where you put your pen down and where you should finish. There's bigger ones if anybody wants one. I don't know. You don't have to use them if you don't care about your graph. Homeworks, like it's your call how precisely you graph. On quizzes and tests, I'll always give you the grid to do it. When we connect these lines, Jade, did you discover what you did wrong? Okay. This green function has 2 boundaries, right? So I'll put my pencil on a boundary and I'll draw it until when?
The next boundary.
Until I get to the other boundary. So if I did this one, if I do this, am I correct?
No.
That green function only works between x's that are -1 and -3, excuse me. So when I'm connecting these, I'm going to go, if I have 2 boundaries, I'll start at one boundary and I'll go to the other. Okay, for the red function, here's one boundary, here's the other. Same thing, I will not pass through it, can't do that. I'll start at one and draw a straight line until I get to the other. Last one, exact same thing. Start at the boundary, draw till I get to the other boundary, and we're done. What's the obvious follow-up question that I'm about to ask you?
Domain.
Oh my gosh, what's the domain and range of this thing? The domain question will get easier and easier over time. It's okay if you struggle with it right now. I'm going to be honest. The range question, even like I'm pretty good at math, the range question can be hard for me to think about because domain is an easier thing to answer just by looking at an equation. The range can be challenging, but we'll get there. We'll build it up together. All right, I'm going to give you 30 seconds. I want you to write something down, be prepared to cross it out and fix it, and to read me what it is. We'll pause, 30-second gap. Likely, got it. -3 to 3 is our domain. Now, as we look at it, does the vertical bar help? Like when I do this, do you guys know what I'm doing this for? Okay. I assume it's helpful. I would use a straight edge on your page if I were doing it. But check it out. What's the leftmost point that I can touch the function? So I start here. Am I still touching? It gets weird here, but am I still touching? I touch up here, but not here, right? So if I just said, am I touching? Yes. Am I still touching the function? You say no, Kian? Right here, it's touching it, isn't it? Well, now it's the red one, but it's like this is the same function.
Oh, yeah.
So I'm still touching it, right? Still touching my graph. Here it gets weird, but am I still touching it? I pass through the hole here, but I touch it here. Still touch until where? Till 3. So I started at -3 and I went all the way to +3. When I did a question similar to this with first hour, I'll show you what they answered the question as, which if you have, don't count yourself wrong yet. Do I touch -3 and 3? Do I actually get to choose those x values? Closed. Closed. Yep, I do. Boom. Okay. What I got a lot of from first hour. I would encourage, if you don't have this written down, don't change yours. But what I got a lot of was -3 to -1, union 1 to 1, union 1 to 3. Does this say the same thing?
Yes.
Notice I include -1 here, which is what happened here, but I don't include it there. Same thing, I include 1 here. These are the same intervals. Somebody, if it's easier to think about in 3 pieces, I'm good with it. I like the 1 piece. All 1,000 episodes or something. I don't know. All right. How about the range? Oh! I just pinched the heck out of my arm. I didn't scream like a girl. That was Declan. What about the range? What's the lowest that we ever get close to? -3, and it happens right here, I believe. Do we actually touch it?
No.
So -3, and then we're going to work this line up. We're just going to see, does it touch somewhere? At least once. So here we go. My parentheses say I get really close, but then I'll start. Am I touching it? Am I still touching it? Still touching it? I feel like an annoying, like, younger brother right now. Still touching it? Still touching? Until where? Do I touch there?
No.
No.
Get close enough.
So how do I indicate that I get really close without actually touching? We're done.
So if it's open, is always a parenthesis.
Unless it gets filled in elsewhere. So like if I had another part of the graph that was, like, let's pretend the green one, instead of being down there, did this. And I'll pretend, like, don't change yours. If that was my first graph, what do you think? Would it be closed at 3 or open at 3? Because there's a close point at 3. Yep. Awesome. Great question. All right. Cool with this? All right. We have one more weird type of function to look at. Okay. I'm going to tell you straight up. We don't have to write it down, but I'm going to talk at you guys for like 2 minutes about something. Okay. I'm going to make a claim. Don't write this. This will be kind of like our math brain break, but we're already a day or 2 behind because 4 days a week. So we're going to keep going. I'm just going to gloss over this one. Okay. Do you guys know how taxes work?
Yes.
So you file taxes. Okay. You probably don't know how much money I make. That's okay. It's public record. You can look it up. You can see it. There's a signed contract. Yeah. Yep.
What?
I don't even know how much money I make, just to be honest with you. Like, I don't know.
Salaries, right?
Yep, I make a salary that the board approves. You can see my salary. 100%. Yep. Okay. Here's the deal. If you work a job in this country, do you always pay taxes?
Yeah.
Everybody?
Unless it's not under the
It's
table.
like, state tax.
So we don't have state taxes here, thankfully.
Oh yeah.
Now, the way that it works in our country is we use tax brackets. You've probably heard that. I'm not gonna teach you how to file your taxes right now. But when we look at taxes, and we're gonna build this into the math stuff, and we're gonna use an example that's partially made up, just so you know. I did not check the numbers, but we're just gonna work with them. So here we go. Example, let's look at taxes. And I wanna see what this graph looks like. Okay. Where you stand politically is going to change the answers that you give. Do we have a flat tax in this country? Meaning, do I pay the exact same percentage of my wages as Jeff Bezos?
No.
No. Who pays more?
Jeff Bezos.
Maybe. He should, theoretically. More money or more percentage?
More money, same percent, right?
Maybe. Is it fair? Like, again, I don't know the answers. If Jeff Bezos makes $1 billion, 10% of that is what, 10 million? Okay, if I make $100,000, then I would have to pay 10,000. Yeah, maybe that's fair. Like, I don't know. Who knows? I don't know the right answer. Anyway, check it out. In our country, it doesn't work like that. We don't use a flat tax. The way that we work is if I make X amount of dollars, each time that I move into more money made, I pay more taxes on it. So there is a portion of our country where if you make little enough money, the government actually doesn't take money from you. So like, could you live here getting $10,000 a year? Like, it would be tough, right? To live here, anywhere really, it'd be hard. But if I made $10,000 in 1 year and the government took 15% of it, like, I'm gonna have to choose between food or housing, like, there's gonna be issues. The government is aware of that. So we're gonna dictate or just draw a small graph, a really, really small graph with fake numbers, okay? So we're just gonna compare the money that you make, that's our x-axis, and the percentage of taxes that you pay. Cannot stress this enough, I'm making up these brackets. Don't know the percentages off the top of my head. Tax, accounting, business stuff is like the most boring thing in my mind, not my thing. But check it out. We're gonna make up these numbers together. Does it seem reasonable that if somebody is like way below the poverty line, they shouldn't pay taxes? Where should we make up our imaginary money? 10,000? Okay, so let's say we have $10,000 right here. All right, now, hypothetically, let's say that they pay 0%. First $10,000, nobody pays any taxes. And then I'm just gonna try to estimate this out. My graph is gonna be kind of crooked so we can fit it all here. What's the next bracket gonna go to? 10 to what? 20, can we go higher? Let's go to 50, we'll split it. Okay, again, not real numbers. What percentage of money do you think people should pay when on that $40,000 that they make from 10 to 50? 10? Sure. Okay, now if I made $50,000 exactly, that means the first $10,000 I didn't pay any taxes on. And then starting here for these $40,000, they took $4,000 from me. So they said, hey, you need the money if you're only here, but if you make more, we're going to take a little bit more. What do you think happens when we add on a 100,000 tick up here? And I'm doing this so I can do these bigger jumps, right? Let's actually, we'll go 250,000. For somebody's money between 50 and 250,000, that next $200,000, I don't, again, making it up, maybe 20% because they make a lot more. Okay, this is the structure that our taxes work. The numbers are different, and there's a whole lot of other things that go into it, but this is essentially what happens. I just want to see what actually occurs when we track how much of our money is going to taxes. For this first 10,000, how much should we say they have to pay? So it means that if this is my paycheck, from 0 to 10,000, up until that $10,000, I pay 0% taxes. And then let's say that I make more than 10,000. For 10,000 on, I'm going to pay what rate did we decide?
10.
So starting at $10,000, my very first dollar, 10% of it goes to the government. And it stays that way up until we get to 50,000. The second I make $50,000, that first dollar afterward isn't taxed at 10%. According to this, it would be taxed where? 20, which means we would start all the way up here, and it would stay at that 20% for that $200,000. Is there another step that I'm just going to run out of room with? Another bracket? Yeah, maybe 250 to $1 million, they pay 30%, and we would just get another piece, and I'm not even going to put the numbers, but it might look like this. Okay, in our country, there is a maximum where this will go. It will not really go up forever. In the 50s and 60s, when socialist ideas were a little bit stronger than they are today, the highest that they would take from you is like 50%. Now, some really radical people thought that, hey, maybe after they make $1 billion, maybe the rest of it should just go. Like, and whether you agree or disagree doesn't matter. But I don't know. Again, what I believed isn't necessarily right either. Okay, but check this out. What does this graph look like to you?
Piecewise function.
It does look like a piecewise function. What if I wanted to just do a little... Looks like what?
Stairs.
Stairs, right? So check it out. We have a whole family of functions that are piecewise functions, 100%, but we get this lovely definition, and this is our last thing that we're going to write. We might have a couple minutes for homework. You will have homework. I'm going to put it here because I'm out of space on the bottom. We're going to look at step functions. Now, there's a really common one that shows up that's not this, but I think the tax example is much more relatable because you guys probably will all pay taxes or you'll go to prison. But here we are, step functions. We're going to just say that these are piecewise functions. and I'm just actually going to say piecewise because I'm trying to save time, that look like what? They look like steps. Now, for these, there are a billion different contexts where a piecewise step function would show up. Have you ever bought anything on Amazon and if you look at the side, it says, oh, if you buy 10 of them, 0 to 10, you pay $20 each. But what if I bought 11 to 50? Are they still going to charge me $10 each? Or might they give me a little discount because I'm buying a lot?
Discount.
Everybody okay with if I buy in bulk, I get a discount? The bigger bulk, the bigger the discount. That would be a step function as well. It would be what's the cost per item for this range. In these, the only weird part, the weirdest part, help me with this particular function. What's the domain of the red one that we have? I'm not even going to write it. Here I am. I surely have a straight edge somewhere. Am I touching?
Yeah.
Ooh, that's glass. Okay, I'm touching. Am I still touching?
Yeah.
It gets weird, but am I still touching?
Yeah.
Still touching?
Yeah.
Still touching?
Yeah.
And this is a weird one because it's money and the context is here. Conceivably, is it possible that somebody has unlimited income? In practice, not really. But you can imagine that there's people out there making $1 trillion a year that we just don't know about. There are people that make trillion. Trillionaires aren't really like known in the world. I guarantee there's trillionaires in our world though. Okay, so our domain started where?
0.
0. Why doesn't it make sense to start at -5?
Because that would work.
Negative money.
Yeah, how do you start the year owing the government no. Okay. So, 0 to conceivably infinity, right? Okay, here's a weird one. That's not that weird. What about the range?
Well,
Wait, how?
the range would be very.
There's 0. Is there anybody, according to this made-up system that we just did, super simplified, anybody paying 3% tax?
No.
Or 7?
No.
No, so somebody pays 0, or they pay 10, or they pay 20. We don't get a whole range of numbers. We get just a list of specific numbers. Now, in algebra and mathematics generally, there's a really common function. I don't think it shows up on your worksheet. It's called the floor function or the ceiling function. We'll deal with them on a random day when we can fit it in. Cool. I skipped a little bit of the stuff that we hit first hour because I'm still trying to figure out the timing with first and sixth being, 5 and 4 days a week. Let's see how the homework goes.